All right, this is on worksheet 13A, properties of rational exponents. This is part 2. We have already reviewed the properties of exponents, which if you add multiply like basis, you add the exponents, but this time the fractional exponents. Remember what rational means, ratio, which means you can write it as a fraction, okay? That's what these are, fractional exponents. So if you're going to do 3 to the 1/2, times 3 to the 3/2, you add the exponents, just like the rule was, but they happen to be fractions. Excuse me, thank you. This would equal 3 to the, what's that? 3/2 plus 1/2 would be 4/2, which reduces to 3 to the second, which is 9. The second rule is power of a power rule. The last one was the property was the product property of exponents. This is the power of power rule. We multiply the exponents. So here, if we have 4 to the 3/2 raised to the second, we do 4 to the 3/2 times 2. The 2's we cancel out, giving us 4 to the third. And then we can evaluate that, which is 4 times 4 times 4, or 64. The third rule is we have a product raised to a power. You apply the power to both terms within. So if I have 9 to the 1/4 to the 1/2, 9 times 4 to the 1/2, I do 9 to the 1/2 times 4 to the 1/2. And that 1/2 exponent means square root, or the index is 2. The square root of 9 times the square root of 4, which would be 3 times 2, which is 6. Now you might say, well, why didn't you just multiply the 9 and the 4 and then take the square root? You can, okay, but I was just illustrating the property, right? The next property is the property of exponents being negative, which is you write the reciprocal to get the exponent to be positive. So 5 to the negative 1/2, or 25 to the negative 1/2, would be 1 over 25 to the positive 1/2. And the 1/2 exponent means the square root. So we have 1 over the square root of 25, which is 1/5. The fifth rule is if you divide a quotient, the property of quotients, a quotient is a division of two numbers. If the bases match, you subtract the exponent. So this one we have matching bases. We do 6 to the, is that 6/2 or 5? I can't read. There you go, 5. I was going to say it wouldn't make sense for it to be 6/2. 5/2, and then you subtract from that 1/2, which gives you 6 to the 4/2, which is 6 to the second, and the answer is 36. Okay, and finally, the last one, if you have a quotient and it's raised to a power, you apply the power to both the numerator and the denominator. This would be 8 to the 1/3 over 27 to the 1/3. The 1/3 exponent means the cube root. So you have the cube root of 8 over the cube root of 27. I'm hoping that you're getting those memorized. What do you cube to get an 8? 2. So the cube root of 8 is 2. And what do you cube to get a 27? 3. So the cube root of 27 is 3. Really want to know those by heart. All right, so those are the examples of illustrations of all the properties, and now we're going to do some practicing. So part 1, it says use the properties, or we can go forward and backward with them. Okay, so using the properties of rational exponents, we're going to simplify. No calculator. Shouldn't be even using your calculator right now. Leave your answer with an exponent. Okay, so we got 5 to the 1/2 plus 1/4. You add the exponents. We need a common denominator, so we'll multiply the 1/2 by 2, top and bottom. So we have 5 to the 2/4 plus 1/4, and that is 5 to the 3/4. It said to leave it with rational exponents. Leave the answer with an exponent. You want to read those directions. This property, you're raising the two things in here to the second power. So you're going to use the power over power property, which you multiply the exponents. 1/8 times 2, excuse me, 8 to the 1/2, you multiply the 1/2 by 2, times 5 to the 1/3 times 2. When you multiply a fraction by a number, you multiply the numerator. So this would be 8 to the 2 over 2, times 5 to the 2/3, and 8 to the 2 over 2. That's 8 to the first. So we just have 8 times 5 to the 2/3. That's the end of it. Now, it said to leave the answer with an exponent. This could be rewritten another way, but I'm just leaving it with the fractional exponent. Because that does mean 8 times the cube root of 5 squared, or 25. You could have written that. That's actually equivalent to this. But back up here. I circled the one that we were expecting. Multiplying 2 to the 4 times negative 1/4 times 3 to the 4 times negative 1/4. If you know what the answers are before you show it like this, that's fine. 4 times the 4th would be 1. So this is negative 1. 2 to the negative 1 times 3 to the negative 1. And that's 1/2 times 1/3. So our answer would be 1/6. We would go ahead and finish that one out, because you don't want negative exponents in your answers, ever. This one power, we're going to multiply 27 to the 2/3 times 6 to the 2/4, and then you should reduce that. I do realize that many of you may recognize you can evaluate 27 to the 2/3 rather easily. Cube root of 27 and then square it. So it didn't say to do that, so I'm not. Okay, because it said to leave them with the exponents. So 6 to the, I guess I could have left this. I don't know. This one I didn't have to do it. I really didn't see any purpose of not writing it to 1/6. This would be 6 to the 2/4 and 6 to the 1/2. Okay, so I kind of blew through those pretty quickly. Now what? Well, this is a little harder because now we're dividing, and you have to think of 7 as having an exponent of 1. So we're going to have to subtract the exponents, bless you. 7 to the 1 minus 1/3. What is 1 minus 1/3? How many thirds are in 1? 3. Okay, so that'd be 2/3. If you made a 1 into a thirds, it's 3 over 3. Is that better? Okay, this one, the 4 is an index, and that is a root. You remember my trees? The roots are on the bottom, power on the top. Okay, I can't get it to move. Okay. All right, so this would be x to the 3/4, and then over y to the 1/4. It could be written like this first if you wanted, and then applied the power. Okay, but that's not necessary if you understood where I got it. 7, we're going to have our bases, subtract the exponents. 5/6 minus 2/3. I need a common denominator. So I'm going to multiply 3 by 2 to get a 6 on the bottom, so I have to do that to the top. So that would give me x to the 5/6 minus 4/6, which I get x to the 1/6. And then this one, number 8, y to the 1/4, subtract from that 3/8. I need to get my terms in common denominators, so I have to multiply by 2 top and bottom on my 1/4. I got y to the 2/8 then minus 3/8, which gives me y to the negative 1/8. I can't leave my exponent negative, so this is 1 over y to the 1/8. Please make sure I can tell that these are exponents and not fractions that are multiplying the variable, okay? They got to look like they're up a little bit, all right? I mean, when I see this, it makes me crazy because that doesn't mean the same thing, okay? Don't do that. It doesn't make me crazy. It just makes me have to write all over your paper until you don't do it again. So I don't have to give you a point off or something. All right, use properties of radicals to simplify. All right, so this is part 2. Now, if the index matches, you can multiply what's underneath. So we're doing the cube root of 4 times 16, because they're both in cube root jail. We can let them hang out. That's the cube root of 64, and I can answer this. I want to simplify it as far as I can. What is the cube root of 64? What number multiplied? That would be 4. Remember your little green chart to help you get those memorized. I want to use the property of quotients for this because I could rewrite this as one big fraction with the 4th root of 162 over 2, because then I could reduce this. And 162 divided by 2 is 81. And 81 is a perfect 4th root because 3 times 3 times 3 times 3 is 81. So the answer is 3. Good, Dan? I saw a little face there. I was making sure you're all right. Oh, it was good. Okay, you're fine. I just want to make sure. All right, then I got cube root of 25 times cube root of 5. That'd be cube root of 25 times 5. And you don't have to write that step. You can just go straight to the cube root of 125. Is that a perfect cube? See, it is. Yes. The cube root of 125 is 5. And this one, the cube root of 32 divided by 4 is the cube root of 8, and that is 2. Does, doesn't it? It's a 2. You'll just pretend it is. Okay, now this is going to be a re-explanation of how I've been showing you why I've been telling you to divide by the index. Okay, because remember when you have a root, whatever, that power in the number n, that's the power, and then the index goes on the bottom. So that's why I was telling you to simplify radicals, to divide the index into the power to help you know what comes out. So this will re-illustrate that. So I'm going to rewrite the 32 as 2 to the 5th. Then I've got an a to the 5th, b to the 10th. If I use my properties of rational exponents, I can rewrite this as 2 to the 5 over 5, a to the 5 over 5, b to the 10 over 5, and then reduce them. So that would be 2a, b to the 2nd. Yeah? Nope. No, you do not. If you understand the method I've already taught you, or the way I've explained it before, because that's why I usually try to explain things more than one way, so that more than one person, the way you learn or way it helps you to think about it, whatever one works for you, that's the one I want you thinking, okay? And then you don't have to write all that out either. Because if you're realizing you're to divide by 5, like I've been saying, I just hadn't shown it that detailed every time, okay? The bad part's when you get the remainders. That's, that's probably the only hard part. So first of all here, let's just realize that we can apply that root to both. So we got x to the 6/3 over y to the 9/3, the root on the bottom, and then reduce. So that'd be x squared over y to the 3rd. I'll rewrite 16 as 2 to the 4th to help you understand we're looking for a multiple of, let's say, powers of 4, basically. Now, e to the 9th is going to have, it's not divisible by 4, so that's going to have one of those remainders. So that's all you need to pay attention to here. Divide 4 into 4, you get 1, so I get a 2 and a d coming out. 4 goes into 9, so I'm not writing it this time. I'm going to go back to the method I already mentioned to you with the square roots. 4 goes into 9 twice, so e to the 2nd comes out. 4 goes into 20 evenly 5 times. There, f to the 5th comes out. And then I still have a 4th root of, and don't forget the 4, the index has to be there. And the only guy that didn't come out all the way was the e's. I know that's saying it not technically correct, but I think kids understand what I'm talking about when I say it that way. Okay, this is like you have 3x plus 2 multiplied out 32 times. Holy cramoly. If we're going to take the 4th root of that, I'd rather do this. 3x plus 2 to the 32nd divided by 4. And that will be 3x plus 2 to the, you got to have the parentheses, to the 8th. And remember, you can't apply that power in because this is a sum, not a product. Okay? This would mean 3x plus 2 times 3x plus 2 times 3x plus 2 times 3. Ugh. I don't want to multiply that out, so you can just leave it like that. Very long. Well, we will look at the binomial expansion theorem in the future and be able to figure out what the terms were. All right, so here's practice. So you're going to practice now. You may ask me questions. You may ask me questions on other homework. You can be working on the quiz preview. I think I'm going to pause, and then if you guys ask me some questions I think would be valuable for me to record, I will start it up again. But you got work time now. Okay, quite a bit of work time. I have a question on 18 on this paper. Oh, you don't have much to do on that. It just says simplify expressions using the properties of radicals and rational expressions. You can't go really far with this. All I want to do is you to apply it to both the top and the bottom, and that's really it. Unless you wrote the 8th root of 2 over the 8th root of 3. Yep, that's all you can do for that one. Cameron? Sure. And who else? Gwendolyn, was that you, Gwen? 20? Oh, yeah, I love that one. Okay, so let's see if you can help me figure it out. I mean, obviously I know, but how can you write a square root as an exponent? Okay, how can you write a cube root as an exponent? So now what do you do when you have power of a power? Multiply. Is that kind of neat? So what would that be? Oh my gosh. Okay. Why? Two times 2 times 2, 8 times 3, that'd be 2 to the 1/24th. No, I'm not going to do a bunch of them, but something like that we could, but I don't think it's on the quiz. But why not show you what that means, you know? Not that bad. Okay, anybody have something else right now? 19. Yeah. Well, you could write 7 to the 1/2 times 3 to the 1/2, or you could do the square root of 21 and then write 21 to the 1/2. Brooke? No, you have to have matching bases. The only way you can subtract the exponents is if the base that the exponents are on is exactly the same. 21? Okay, now, let's not throw things. The square root, you can write it as one big one, so you'd have 20 over 5, right? And then 20 divided by 5 is 4, so this would be the square root of 4, and that would be 2. What's the square root of 1? What's the square root of 1? That's what you're talking about. Yeah. We're not there yet. We'll do that in the quadratic unit. Oh yeah, we have a whole unit 2's quadratics. That's next. You will learn way more than you have ever learned about quadratics very soon. Completing the square, graphing, you name it. I think it's unit 2, it's quadratic. What? Yes, it is. 2 or 3? No, it's 2. Okay. Yes. Oh, I should make sure I'm looking. Caitlin. 26, Caitlin went, so I'm going to go there. All right. The reciprocal first, right? Now, did the directions say to simplify? Okay. Now, this is not really that simplified. So if I rewrite this as the bottom is the root of 2, this would be the square root of x to the 7th. Agreed? Okay, now, what is the square root of x to the 7th? Well, the index is 2, so 2 goes into 7 3 times. That'd be x cubed times the square root of x. One of them stuck in there. So remember, we can't leave radicals in the basement. We don't want to blow up our basement. So we multiply by the radical that we don't want, and you get them happy and put them upstairs. So 1 times the square root of x would be the numerator, and then the bottom, square root of x times square root of x is x. X to the 3rd times x will be x to the 4th. Scott? Multiply. How do you do 3/5 times 1/6? 3/30, and then reduce x to the 1/10. Honestly, Caitlin, I think that it was just expecting you to do that. But I want you to know about this, okay? So we should be able to do that. Got a question on the quiz preview. Oh, that's not that right. Quiz preview. We'll find that. Okay, number 2 on the quiz preview, I've been asked to factor. This one is a trinomial. And 3x times 3x is 9x. Now, how do I know I'm doing this right? Okay, one's a negative, this is a negative, this is a positive. So these have to have the same sign, because when you multiply the 5 and the 5, you got to get positive 25. And then I recognize that this middle term is the doubling of the product of these two numbers. So it's called a perfect square trinomial. The number here is a perfect square, the number there is a perfect square. So you try that and see if you get the middle term. And this is negative 15 and this is negative 15, so I got the right sign. Okay, that then you should rewrite, and I will take off half a point if you do not rewrite it as the quantity 3x minus 5 to the second power. That would be half a point. It would be a 2-point question, probably. Pardon me? 3? Oh, I love 3. Here's the one. What time do we go? 39. There's 6. I guess it's 5 minutes. We still got people that leave early. Okay. This is the one I said when we started factoring that people will miss on the quiz Friday. And it's the easiest one in the paper. What's in common? It's just the 4, you're saying. Thank you. You factor out the largest monomial factor that you can from all of the terms in the parentheses or that are there. Yes. Heck yeah. It's not going away. You have a unit test next week on, yeah. Intervals are still on there. Knowing the domain and the range all year. I did. No. Nope. Yes, you may. If you want to come in and look them over, but you got a preview of the unit test as well. I'll give it to you tomorrow. You'll have a big review that's got everything that's going to be on the test. I do not let the quizzes out because I don't want to have to rewrite them every year. And I already have 2 and 3 versions. I don't want to do it again. I got enough other work. I'm trying to rewrite stuff for geometry. So, I mean, I revamp things, but I don't let them out because, too, I want to be able to use them for retakes. I want to, I don't want the kids next year to have a copy. You know, there's a reason that we keep our quizzes and tests. And it's not that I don't want you to have the use of them to study. That is certainly not it. If you would like to come in, you have the right, certainly can go over anything you want with me. I'm here every day after school.